Hi, welcome to lesson 5 of IB Physics at Edu Solutions Institute. So today's lesson will be focusing on Hooke's law. So last week's lesson we looked at frictional force, either static frictional force or dynamic frictional force. So we're still on the concept of forces. So Hooke's law basically is in terms of forces. Now, when an elastic object experiences an applied force, meaning something is added to it, then it will either do two things. It's either it's going to be compressed, meaning it gets smaller, or it's either it's going to be extended, which means it will get larger. Now, the ability of this object, after you remove the applied force, to come back to its normal position or normal size is due to what we call an elastic restoring force. So the important word here is a restoring. So restoring means we're going back. Alright? So when you apply a force onto an elastic object, if it causes it to extend, then the restoring force is the one that causes it to come back to its normal position. Now if you compress something and then after you release that applied force, it's going to come back to its normal position, then the restoring force is responsible for that movement. Now, if we take this example where we have a regular spring, right? This spring is not extended, so it has no external masses applied to it, so therefore this length we can call L. Right? That's our original length. Let's put Li, initial length. Now, after we apply a mass to it, then this spring will extend, right? So it extends by, if we go here, extends by this amount, right? That amount, we will call it E, or extension. So when we apply this force, or this mass, it produces this amount of extension. Now, we can call this mass, right? And we know that this mass from its center will generate a force downward, which is called weight, which is just M times G. And that is your force, your applied force. Then call that FA, applied force. Alright? Now, in this diagram, after we release this mass, or take this mass off the spring will generate or provide or produce a force to pull it back up. And that force is called a restoring force. Let's call it Fs. So, in this formula here, based on Hooke's law, that tells us that the amount of force added to an elastic object is proportional to the extension it produces. And therefore, from that we get that your restoring force will be equal to negative K, which is called your spring constant, times your extension. So E here is your extension. So what this means is the same amount of force that is used to extend the object is the same amount of restoring force that is used to push back the object to its normal position. So we can say that F applied equals to F restored. Right? So that is based on Hooke's law right there. Now the negative represents because it is a force that is opposing to your applied force. So we use the negative to show that it is an opposing force to the applied force that we use. Now, what does the spring constant tell us? Now, the spring constant tells us how stiff the object is in terms of expansion or compression. Or, in technical terms, it tells us how much force we need to actually extend the object a specific length or to compress it a specific length. So, for example, if we say that K is 200 Newton per coulomb, Newton per meter, sorry, then what means is that for every meter that this object will extend or compress, we need 200 Newton force to do that. So therefore, if we have another K that is 50 Newton per meter, then that means that this one has more elastic ability than this one, because this needs a small force, 50, to extend it 1 meter, while this one needs 200 Newton force to extend it by the same meter. So therefore, this one is more elastic than this one. So that's where the principle of Hooke's law comes in. It can be applied in numerous ways, right? So from basic spring motion to extend a spring or to compress the spring, to building bridges by engineers, where we know that big objects will go on these bridges and they will produce some compression. Alright, so therefore we need to know how much restoring force that this bridge can produce in order for it to actually come back to its normal position. Because if it doesn't come back to its normal position, then it's actually going to be called a deformed object. And once it's deformed, then over a period of time, it will break. Right? So that's the importance of Hooke's law. Hope you learned something today, and I'll see you next week, where we continue to learn about the IB syllabus. Thank you.